Video 22, Random Variables. In the previous videos we have seen the overview of probability, conditional probability and Bayes theorem. Now we start with random variables. What is the definition of a random variable? Definition. Let S be the sample space associated with a random experiment. Random experiment means it is an experiment in which we do not know the outcomes. Right? Sample space means set of all possible outcomes with a random experiment, and let capital R denote the set of real numbers. A random variable, I will write RV for random variable, is a function from S to R. So random variable is a function from S to R, where S is a sample space or the sample space associated with an experiment, and R is the set of all real numbers. Now let us see by an example what is a random variable. Example: consider the random experiment of tossing a coin twice. Then yes, the sample space is given by HH, HT, TH, TT. So this is our sample space. Let X from S to R be defined by the following arrow diagram. So what is that arrow diagram? So S is the sample space consisting of one outcome HH, HT, TH, TT, and then we have all real numbers. We are going to define a function from X to R such that X takes XX to say 2, XT to 1, TH also to 1, TT to 0. It contains infinite number of real numbers. Okay, so this is we have defined a map, a function. Let X be defined by the following arrow diagram, like that. That is, X takes the point HH2 equal to 2, X of HT equal to X of TH equal to 1, and X of TT equal to 0. That is, X denotes the number of heads. In HH we have 2 heads, therefore we associate that sample point HH to 2. In HT and TH there is only 1 head, so we associate those 2 points to the real number 1. x of t equal to 0 because there is no head. So x is a function. X denotes the number of heads. That is capital X is a random variable denoting the number of heads. We can define many functions from Y to R. Let Y from S to R be defined by Y of HH is equal to 0, Y of HT is equal to Y of TH is equal to 1, and Y of TT is equal to 2. Then Y is a random variable denoting the number of tails. In fact, we have defined many such functions from S to R, from the same sample space to R. So every function is a random variable defined on the sample space S. The sample space is obtained with the help of a random experiment. So this is the definition of a random variable. So this completes video 22.